Welcome to clickmyproject.com. Now we discuss about the product for VLSI design for support vector machine based speaker verification system. Next we see the abstract for the product. A biometric system makes a pattern recognition decision in occurrence with a biometric feature extracted from the human being. In recent years, various human characters such as face, speech, fingerprint, and the iris have been considered as deterministic feature for automatic biometric recognition. In this brief, we will address an hardware design of speech-based biometric system. Example for speaker recognition system. This brief presents the chip implementation of a support vector machine-based speaker verification system. The proposed chip comprises a feature extraction for SFE module and another SVM module and a decision module. The SFE module performs autocorrelation analysis, linear predictive coefficient extraction, and LPZ to substrum conversions. The SVM module includes a Gaussian kernel unit and the scaling unit. The purpose of Gaussian kernel unit is a first evaluation the kernel values of a text vector and a support vector. 4 Gaussian kernel processing elements are designed to process 4 support vectors simultaneously. Each processing element are designed to process 4 support vectors simultaneously. Each Gaussian codic process architecture is proposed to calculate the exponential value as well as the Gaussian kernel unit. A scaling unit is also developed for a SVM module. The scaling unit is used to perform the scaling multiplication and the remaining operation of SVM decision values evaluation. Finally, decision module accumulates the frame scores that are generated by all test frames and then compared with thresholded to see the test utterance is spoken by the claimed speaker. The design is chip characterized by the high speed and ability to handle the large number of support vector in the SVM classifier. Next we see the flow diagram for the product. Our overall architecture process was based on the image and signal processing system. So we implement the MATLAB and system based process to implement the Xilinx 14.2 architecture. First of all, our overall process is to identify the speaker verification system. So we browse the given input voice samples for overall database voice signal. Then to filter the input voice signal. Our filtering process using the low pass filter for overall filtering architecture. Then to apply the LPCC feature extraction process. This feature extraction process to identify the overall information for selected voice signal. These 3 processes to be implemented for MATLAB 2013 A software. Then to pass the MATLAB results to Xilinx refer. So we use the calling for the winopen command for the overall Xilinx software process. Then to design the Gaussian kernel unit for normal processing element architecture. Our overall SVM architecture consists of normal processing element architecture and the exponential processing element architecture. The normal processing element architecture is used to identify the kernel unit based on the Gaussian process. Then to apply the Cardic based exponential processing element. Our Cardic process was mainly used to reduce the overall shift and rotation operation for SVM classification architecture. Then the architecture results is applied to the scaling unit function. This function to identify the support vector and the test vector, then to classify the overall test results. The data support vector to identify the overall information for reference unit. Then to passing the all pre-processing support vector work for the same test vector processing results. Then to set the threshold level to identify the speaker information for variation for overall support vector and given selected test vector. Then the response comparator to check the test vector and the support vector difference level. The difference is minimum level to satisfy the S results, then to process the next. The difference level is maximum to identify the next test patterns. The final matching results for overall voice database and the samples, then to identify the which voice to be selected for overall architecture, then to identify the process using the label for each and every voice signal, then identify the what the information to present at the selected input voice. These processes are developed in Xilinx 14.2 software. Next, we see the final output for the product. First, we select the main function and to run the first of all the browse the input selected voice for overall database signal, then to select the voice signal and to filter the voice signal, then to apply the feature extraction process. This process to collect the overall information and to write the text values, then to open the Xilinx software and to read the text values for Xilinx software, then to read the overall voice information and to process for overall information collection process, then to apply the SVM classifier architecture for VLSI software and overall SVM classification architecture to create the VLSI software, then to process for overall architecture results. These results to identify the informations for voice collection process. This is the voice collection process to activate the clock signal, then to collect the all voicing signal for overall SVM classification process. This is the overall information for voice collection process, then to run the output selection process. This selection process based on the clocking and reset signal to get the what are the information presented the selected input voice, then to apply the clocking sequence, then to apply the clocking sequence without reset signal. This reset signal our selected voice to read the voice information for boy. This is the simulation process for overall